Swayam Prabha. Digital India. Educated India.
Good evening to all of you. So today in this lecture, I am going to cover some of the international practices and case studies on coastal protection. So the problem of coastal erosion is very common all over the globe, and the practices that are being adopted, we don't have many options, only few limited options, but only with these limited options you have to make sure that it is quite effective. So that is what I am going to tell you in this lecture. So the contents of this lecture will be driving forces in the coastal zone and extreme events along the coast, climate risk index. This is one which is being used worldwide, and then I will try to look at what are the options we have. So the options: defend, adaptation and retreat. Then I will look at the coastal protection measures. Some of these measures might have been covered, and I understand that the driving forces in the coastal zone has already been covered in the previous lecture by Professor Sanasraj. Then we'll move on to case studies. Then finally, this recent topic which we have just started, that is multi-purpose structures. So instead of having a structure for a single purpose, we try to look at multiple. Then finally, I will talk about extreme flow mitigation measures. This is based on a recent ongoing project with German Institute, RWTH. Then I will try to summarize. So if you look at the driving forces, instead of going into the mathematical equations, formulas, etc., I just show you this picture, which is almost like self-explanatory. So you have the currents from the inland as well as the wave-induced nearshore currents. The wave-induced nearshore currents, as you can see, this is going to drive the sediments that are coming in suspension. So you have sediments that are moving along the river and brought to the coast, and we also have the driving force, the sand moving along the coast. So these two driving forces are going to dictate the stability of the shoreline and also the stability of the mouth, whether it is going to be closed or it is going to be opened. Only if it is getting open, only when it is open throughout the year, only then the river, inland navigation, all those things, the importance of the river will be felt. If it is closed, then that will lead to a lot of other issues, like we do have some problems like the rivers along the Chennai, Tamil Nadu getting blocked. One such thing is the river Kuam in Chennai. Then during a storm, how do we handle this problem? How do we handle this kind of a situation when you have storm waves? How do you respond? So that is what I am going to explain with some of our. Then once you have these driving forces, how the sand is being removed from the beach. This is another problem. So you have the interaction of the driving forces and the beach, the characteristics of the beach. So that is where we have to understand and we have to study. So since the driving forces are already known to you, now we look at the types of coast. So what we have in mind mostly is a beach, but actually the beaches or the beach slopes can be of different types, as you can see here: clayey bank type of coast and intertidal muddy coast, the sandy coast and sand dune coast. So each one of this has its own characteristic and you have to deal with it. So when you deal with a coastal erosion problem, you have to also look at the beach, the beach slope, which is also very important. So why beach slope is very important? As you can see in this animation, this clearly demonstrates the importance of the beach slope. If you look at the top figure, I would prefer going in Goa, going and staying in Goa. Why? Because if provided the tsunami does not come, because I have access to the beach and I can walk up to this area, so there may not be any problem. But if there is a extreme event like a tsunami or maybe a storm surge, then you see what is happening in this case. So you have advantages of a flat beach under normal wave conditions, but it is disastrous when you have an extreme event. But in the case of a deep slope, you do not have much of benefit during the normal wave conditions, but you have the benefit when it is attacked by an extreme event. So the natural protective features of a coastal system, some of these things may be hidden to us, because we stand along the coast, along the beach, so we may not see what is going on under the along the beach slope. So you do have an offshore bar, a small offshore bar, and then over which the waves move, and then you might have some coral reefs or grass, seagrass, etc. And then you have the intertidal area. Maybe sometimes you have some locations you have marshes and also the mangroves, and then you can have some of the beaches like of Mahabalipuram, you can have casuarina trees, etc. So these are some of the characteristics, and you should know the importance of low tide and high tide also. So so you have now experience with the driving force and the characteristics of the beach briefly. And now when you look at the key steps for coastal protection, this is how we have to move along. So first you have to look at the how you can model the nearshore waves. That is a basic thing which has already been covered. And then how these not only modeling, but also you have to look at how they propagate over bathymetry. The bathymetry also is very important, and what kind of resolution the bathymetry needs to be done, that is also important, that has to be assessed, which depends on the problem you are going to face and the area of interest. Then you have to keep updating the bathymetry, and also the topography also is important. Topography is particularly important when you are looking at the flooding. Higher the elevation, you may not have problems, but then you have to, now topography is all the more important under present context in terms of when you talk about climate change. Climate change, you are talking about the sea level rise, and hence the topography, it becomes very important. So like this, and also like after going through this, you try to estimate what is the kind of risk involved, and then once you estimate the risk may be everywhere, but because we cannot protect the entire coast, because we do not have that kind of money, but importance of the coast is needed, that you have to assess, and then you decide about what is the kind of protection measure you can apply for. When you look at continuous shoreline changes, this is what has been given to us, and over the globe you have erosion taking place all over. So for example, our case, you see that this area, India, particularly the east coast of India, is heavily eroding. Certain pockets are heavily eroding, and for example, the Chennai coast north of Chennai harbour was one of the most vulnerable. It was experiencing about 6 meters per year of erosion. We lost something like about 300 to 400 meters width of the beach for over a distance of about 6 to 9 kilometers. And I will be talking about that stretch as a case study which we had solved. So now classification of for extreme erosion. So Estevez and Finkel in 98, they classified sandy beaches as accretion if 0.5 meters per year, then stable for 0.5 to around 0.5 meters per, there is a kind of stable and accretion, more or less same. Then you have erosion, intense erosion, severe erosion and extreme erosion. So, the Chennai erosion, Rayapuram erosion, which is north of Chennai harbour, comes under the last criteria, that is last classification, that is extreme erosion. So, you look at the statement which is given. So, Steves and Finkel had reported that 24 to 25% of the world's sandy beaches are persistently eroding at rate exceeding 0.5 meters per year. Over a steady period that they have conducted, they have taken all the sandy beaches results, etc. And then while 27% are accreting. So, accreting, don't think that is always good. Certain locations accretion also is a problem. For example, river mouths. So, and also approach channels. Then about 16 to 18% of sandy beaches are experiencing erosion or accretion rates of about 1 meter per second. To assess this, we have to look at what is known as climatic or climate risk index, which is CRI. This is a ranking system that evaluates and quantifies the impact of climate related extreme weather events. That may include your storms or waves, droughts, etc. This is covering everything, not just along the coast. Okay. So, this what does it do? It gives or quantifies the impact of extreme events on countries using 4 key parameters. What are the key parameters? Fertility rate, economic losses, and finally losses relative to GDP. So, this is actually brought by an NGO, and the link is provided here, and if someone is interested in knowing more about this, you can contact me or Professor Sanasraj. We can try to give you the information. Okay. So, how do you get this CRI? So, the formula is given as shown here. CRI is a summation of that F, FR, L and LGDP with weighted factors. So, these weighted factors are going to be varying with the component that is based on their significance in measuring the risk. Okay. So, this CRI has to be estimated in order to really assess how severe it's going to be. But normally what they do is severity, instead of going through this already all the mathematical problems, there are many times what happens, there is a catastrophe happening in particular area. So, you have to rush and give, you cannot keep calculating all those index, that is also very important. So, that needs some amount of information, basic information, and you can do some post-mortem using, now we have the satellite imageries, Google Earth, etc. You can do some post-mortem, and then also not post-mortem, you can also understand how the shoreline has been changing, etc., so that you will get some idea concerning what is the rate of erosion or deposition. So, long-term CRI, the same, I have explained what is CRI. Now, long-term CRI, there is what is called as long-term and short-term. When you look at the long-term, you get more realistic picture, whereas when you look at the short-term, you get, which may be a kind of bias, because only for that year it may be valid. For the next year, the entire scenario may be changing. For example, here if you look, you have India in the 6th position when you look at the average over 1993 to 2022. Is that clear? And whereas the other cases, in the case of 22, fortunately we are our country is not there, but this gives you a clear indication, and I mean some kind of a feeling to what exactly is the CRI. The speed is okay? I hope I am not rushing through. Okay. Now, next we move on to the relationship between climate change towards coastal erosion issues. So, what is climate change? What is it going to be? In one sentence I will say, climate change with respect to shoreline erosion if the waves are going to be high, the sea level is going to be high. So, the extent of land that is going to get exposed to the waves are going to be more. That is one aspect. The other aspect is the sequence or the frequency of cyclones. You would have seen so many times the frequency has gone up now. We are getting very frequently the cyclones along the east coast or worldwide also. So, these are all, but then in this in this slide, what I have done is I have explained in more detail about what is happening, what is the relationship between the climate change and the coastal erosion issues. So, now the final thing is the land loss, coastal property, loss of coastal infrastructure, then you have the flooding risk, in fact a loss of life also. During tsunami 2004, you know what happened. Maybe you are not born by that time, but we all know, we have seen what happened to that. And then the tourism activity is declining, yes, because there are several countries which depend exclusively on tourism. If the beaches are not there, the tourism is not going to happen, and then it is going to be a big loss for the country. So, when you look at this slide, you see identification. This is in general what is being followed by different countries, almost all countries. But in this slide you will see Singapore, etc., Vietnam, Malaysia, etc. But this is taken from Dong et al., which was published recently in his paper. But although you have a kind of detailed information like different countries, but it is almost similar to all the countries, what you have to do. See, finally what main thing is identification of the erosion issue. What is the root cause? Unless that is known, you are not going to provide any mitigation measure. Then once you identify the root cause, then you can have, see, the root cause may be due to nature. So, you have a beach, you have a sudden cyclone, scooping of the material, a pocket of erosion. So, at that point of time you should not panic. Why you should not panic? Because you should not go for permanent remedial measures. Maybe if there are inhabitants adjoining the coast, maybe you use what is called as the sandbags to temporarily protect the coast, because whatever sand was removed from the beach might have settled as offshore bar, and then this offshore bar will act as an obstruction, thus reducing the successive waves which are going to come in future later, and thereby resulting in the breaking of the waves slightly far away from the shoreline. What will happen? This will pick up the sand from the offshore bar and then redeposit on the coast, and then over a time you may have a stable equilibrium. So, this you have to have it in mind. Then after looking at that, then if it is a kind of a long term problem, then you have to understand you have to think of some strategic, mitigation measure. What is the strategy that need to be adopted? You have a wide number of strategies that can be adopted, and it's all well established. Only thing is you have to use the appropriate measure for the appropriate problem. And then finally you have to assess. Assessment and monitoring is very important, which several coasts after protection measure it is forgotten. For example, for this one, for assessment and mitigation, monitoring, I'll again have the problem of North Chennai area, which we had been following and doing some work, and I will present that case study later. So, broadly the protection measure can be adopted as defend, adaptation and retreat. So, whatever may come, I will I will stop the force. That means I need some kind of a protection measure, as you can see here. These are called as walls or sea walls. That is defend. Many times it may not work. What happens is, this point is going to be very vulnerable, this area. That is, you have a concrete structure standing on a sand, and although you will have some apron, you have some toe protection, but still you may have problems. The whole structure can't come down. The next method is to adapt yourself. Adapt yourself instead of having, so the entire structure can be resting on piles. And this became quite popular to discuss, particularly after the tsunami 2004. Because they want to stay near the coast, at the same time be careful with the extreme events. So finally, okay, I don't want any problem, I want to go away. This is what is called as managed retreat. So in this connection, we have what is called as coastal regulation zone, CRZ, which is another big area, or coastal zone management. I think she is there who can talk about that. I don't want to cover coastal regulation zone, etc. Now, having exposed to this problem, we will move on to structures to combat erosion. Broadly speaking, we have hard and soft measures. There is a new word that has been coined in the recent past, which is called as natural measures based on nature. So which will be covered in some place, something like this, under a software itself. I will try to cover, and then maybe in one of my subsequent slide, the nature based solutions also will be covered. So under the hard measures, you have seawalls, groins, geotextiles, as well as offshore breakwaters. That is, geotextile is only a material. The structure can be seawall. If you look at the structure, it is only seawall, groins, offshore detached breakwaters. The material you used, you adopt quite different. It can be only a geotube, geotextile, or natural rock, or something else. Even casuarina poles also can be used. Then you have the soft measures, beach nourishment. I will give an example for beach nourishment. Vegetation, also I will try to tell what we have done in the past in our department. Then sand fencing, and then jute mesh and bags. There are so many things, particularly Kerala coast, they have come out with so many using the jute bags, jute. If you look at this the slide, you see the coastal structures. What are all the types of coastal structures we have? We have the breakwaters, which are used for coastal protection as well as for harbors, seawall and bulkheads for coastal protection, revetments mainly for bank protection, then groins for coastal protection, and intake structures for power plants, and then finally outfalls for discharging effluent. Then when you look at the port and harbor structures, we have a number of harbor structures, number of structures, as you can see in this picture. This part I will again talk, or I'll take it up when I talk about geosynthetic products or geosynthetic material. So offshore breakwaters, offshore structures, I am not going to cover in this, but you have the number of the classification under the offshore structures, which is not going to be dealt with in this lecture. So what is hard engineering? So you have breakwaters where you can have the offshore detached breakwater, because of which you can have this will undergo, when you have a structure like this, it will undergo the phenomena of diffraction. So the at the tip of the breakwater on either end. So what will happen is, because of this lee side of the breakwater in between the breakwater and the shoreline will become a shadow area, wherein the wave heights will be less compared to the adjoining area. So the sand will come and deposit in between the breakwater and the shoreline, and thus the shoreline will tend to advance towards the shore, towards the breakwater. So this is one such protection measure, which is not that popular, because the construction point of view, from construction point of view, it is a bit difficult. So now of late people are trying with geotubes, and how it's going to be, how far it's going to be successful, we have to wait and see. So this is quite expensive, and it is not that attractive, although it is performing almost the same role. It is playing the same role as that of the groins, which I will talk about it. So if you look at the groins, these are the groins. The groins can be of trapezoidal section, natural rock, or you can have even palmyra trees, trunks driven, if it is going to be some kind of, maybe to serve as few years. So what the main idea would be, the length of the groin should extend beyond the surf zone, because most of the sand that is moving will be within the surf zone, that is from the shoreline to the breaker zone. So this has to be intercepted. When you intercept such movement, you will have some adjoining problems in the adjoining stretch of the coast. For that, you have to go in for what is meant by transition groins. This has been tried worldwide. In India, this is the first project with the transition groin was of Rayapuram, that was done by IIT Madras, okay, and it was quite a successful project. Then you also have what is called as gabions. Where are gabions used? Because when you want to have large size boulders, when you calculate the size of the individual rock that is needed for groin, depending on the water depth, it can vary even up to about 5 tons, up to 5 tons. So instead of carrying such huge weights, you can have a cage filled with smaller stones, so that the weight is almost same as what it can be achieved, maybe 1 ton or 1.5 tons, then you can use it. But then there are some issues, because if once the wire is cut, then you have problems of the stones being removed and its function is gone. So these are ripraps, which are again similar to the sea walls. You have boulders. Flatter slope is better. Flatter slope will result in smaller size stones. Steep slope will result in larger stones. It's very simple. Okay. So then sea walls, again, this is a concrete sea wall, which is going to be very expensive. But so people resort to the rubble mound sea wall, just a weight of stone maybe about 1 to 2 tons, maybe slightly more also, with a slope of about 1:2 or 1:2.5, depending on the importance of the stretch. And then you have to design, and also the height, the crest elevation of the sea wall is also extremely important. And when you address a climate change, you have to take care of the crest elevation. The coastal zone, the soft engineering, if you look at soft engineering, the purpose of soft engineering is to work with the natural process of the coast. So one area is getting eroded, somewhere else there can be some more sand. So pick up that sand, nourish the beach. So this is what is called as artificial beach nourishment. Or you can have you can create marshlands and enhance the habitats in the marine environment, or you can go in for plantation. The plantation has become very highly spoken after the tsunami in 2004, because there were enough evidence that locations with the plantations really the tsunami run up as well as the height was reduced. So people have been working on plantations and vegetation and etc. So now why all these problems are taking place? Because whatever is happening along the coast is because of the waves inclined at an angle, approaching the shoreline at an angle. When it is approaching the shore at an angle, it will have, when the waves break, it will have two components, because it is attacking the coast at an angle. It will have two components, one along the coast and one normal to the coast. Along the coast is called as the current, the flow is called as the longshore currents, because it is along the shore, and normal to the shore it is cross shore currents. So there are some locations where it is dominated by along shore currents, because the angle of the attack is more. If it is normal to the shore always, then you have mostly cross shore. Okay? So the longshore current is not much. So when you have cross shore and longshore, that means sand is moving along the coast as well as normal to the coast. That is very important. Before you really jump into a coastal protection measure, this is the one thing which you need to assess. If you do some mistake, then the coastal protection measure you are planning is going to be totally ineffective. So this is what is explained. Now assume that there is a longshore current taking place. As in the case of along the east coast of India, you have longshore currents which are moving along the shore towards north, and it is dominant straight from Nagapattinam. From Nagapattinam it is slightly increasing, or with some variation will be there, and there will be movement of the currents in the northern direction as well as in the southern direction. This depends on the northeast monsoon and the southwest monsoon. During the southwest monsoon, June to September, the current will be towards the north, and even during non-monsoon, that is between January and April, also it will be north. But over a year, if you look, the net direction will be north. Having understood now what happens, you look at this picture, this animation. So the top one is the current is moving, and then I am constructing series of groins. What happens to the shoreline here? Follow the shoreline. So you see advancement of the shoreline, and on the adjoining side you have erosion taking place. So alternate zones of erosion and deposition will be taking place. That is, the sand which is moving is being trapped. It is not being allowed to cross. If it is allowed to cross, then it will keep on eating away all the sand which is lying along the shoreline and keep on moving it. So we try to trap the sand. But when you trap the sand, you have to be careful, because this sand is moving, as I said, within the surf zone. So and this is a problem. For example, if you have a river mouth, and if you don't have any protection measure, then this is going to become closed. You know, when the river mouth is getting closed, then you have other issues, the stagnant pool of water, breeding mosquitoes, etc. So you have to have two what is called as the training walls, as you can see here. So this will experience erosion. So probably in order to take care of that erosion, you might have to go in for coastal protection measure, maybe with small groin field, transition groin field. Or this is the one which is for offshore detached breakwater, which we have already seen earlier. So this also can be used as a coastal protection measure when you use a number of breakwaters separated by gaps. The main thing is diffraction of waves that is going to lead to the building up of the shoreline on the lee side of the breakwater, that is in between the breakwater and the shoreline.